I'm Lenny. My real name is Leonardo, but everyone calls me Lenny. First of all, thank you both Tom and Guillaume for organizing and coordinating this entire event, and for all of you to come here, and obviously for Twitter to host it. So yeah, here we are. So yeah, I'm a front-end developer. I work here at Twitter. I joined a year ago. Very happy working at a project called TweetDeck, which is like a separate client for Twitter, which some may know already. So yeah, I'm originally from Argentina, so I moved for the job a year ago, and I'm living here now. So today I would like to talk about a tool that may help you. The idea of this talk is to teach you about some tool that you could use in your projects to improve your productivity, or to maybe increase your creativity with things that you can do to automate more stuff in your day-to-day work. So let's start with these two things. So a quick show of hands, who knows about these two tools, Babel and ESLint? Or. So yeah, most of you. And from all of you, how many of you have gone beyond configuring them? How many of you have actually built a Babel plugin or an ESLint rule? Cool. Okay, so remember those who raise their hands, you should ask questions to them after the talk. Cool. Yeah. Cool. So let's begin with Babel. Let's go back to the basics. So, what does Babel do? Babel is a JavaScript library that receives some source code in the form in some syntax, depending on the thing that we write. It may be ES 2015, ES 2016, 17, whatever, any syntax that we provide by writing, and it outputs the same, a program with the same behavior, but implemented in terms of different syntax, and that's depending on how we configure it. So it may be in terms of the same syntax, or in terms of syntax that is supported for older browsers, in order to work on them. So we can still write modern JavaScript, but still use it in browsers that don't yet support that syntax. But that's not really the only thing that Babel does. So Babel is a bit more general than that, more generic. It really is a tool that allows you to transform that source code into anything. And that's beyond implementing the same behavior in terms of older syntax for browsers. So let's look at some examples. So there's this library called IDX, which was created by Facebook, which works similarly to those of you familiar with Lodash, the get method that allows you to access nested properties and verify that without actually checking for existence of each of the in-between properties. But in a probably more type checkable or statically typed manner. It does it that way. So it works in the same way. So if anything in between the thing that we're trying to access is null or undefined, it returns undefined. But it also comes with a Babel plugin that actually transforms that code into what we would actually write manually by hand if we wanted to check for the existence or not of each of the nested properties. This is a bit better than in terms of performance in production because the other one relies on handling exceptions and trying and catching and handling whatever is thrown, which may be a bit slower than actually just checking for an if-else. But it's a bit tedious to write, so we don't want to write that. We still want to write the other way and have something to be automated for us. So this is what it does. There's another example. This is a Babel plugin that provides you with this magic function called preval, which is implemented in a tagged literal form. So this is actually kind of a function call which receives a string. And you can see that inside the string, there's actually code that when we run the plugin with this source file, it will execute that code inside, and it will replace it with the actual evaluation of the code. So it will return that. So this is also handy when we want to like do some pre-computations at compile time, but we still want to write a more readable format for things that should be like, the things that are more readable in the expression form instead of like the final value. Okay, so now let's look at ESLint. ESLint again is a tool that also receives source code as input in different syntax. So it accepts various kinds of syntax capabilities. But in this case, what it outputs is actually a report of warnings and errors of things that it detects. And it can be any kind of rules. Actually, it provides a bunch of them. So some are like stylistic rules. So if you're like misaligning like indentation, like it will raise an error saying, hey, or a warning, depending on how you configure it. Hey, this is not aligned. If you're like using arrow functions or normal function declarations, depending on how you configure it, it may like say, hey, we prefer to write arrow functions versus function declarations, for example. So that will also be an error. But also it provides you with some like help for JS gotchas, like, I don't know, forgetting to declare a variable and trying to use it. That's also where ESLint is very helpful with. And some other things, like in general, like depending on, like, for example, module resolution when we are trying to import or require some stuff from a CommonJS, Node.js module with CommonJS. But again, this is not entirely what ESLint is capable of. It's a bit more generic than that. So it can actually do any kind of reporting that we want. So you can build your own stuff with it. For example, there is a ESLint rule like you can find in GitHub or in NPM that it's probably more suited for people that have a more functional taste for the code, and they want to make everything immutable, which is like disallowing mutations in their objects. So whenever you find like an assignment to an object, it will be like an error in ESLint. So you should prefer like the immutable way of changing things. There's another ESLint rule out there that helps you to detect like legacy. It allows you to define legacy methods that you no longer want to call in your code, and even suggest with like an alternative. And every time you try to use that, it will like raise an error or a warning depending on how you configure it, and like suggest the alternative so you can change it. That's really cool, but how do they really work? I mean, how are they so like generic, but at the same time people are actually wanting to build plugins and rules on it? Like, and it's not like an entangled mess of code of like dealing with the regexes and strings and all that. So cool. Yeah, obviously it works with magic. Everything that we don't really understand must be that. But in reality, that magic comes from a thing that is called, it's also like mysterious for most of us, that is called a parser. So what it ultimately is doing is like at some point, these tools are parsing this source code into something that is more usable for us to deal with. But how do parsers really work? How are they built? So it's really easy, again, just 2 simple steps. The thing is that we don't really care too much about how a parser is actually implemented, and it's actually probably a very difficult thing to delve into. The good thing is that in the world of JavaScript, there are already like a bunch of JavaScript parsers, probably too many, but this is a solved thing. So for these purposes, we only care about what actually a parser do conceptually. So what does it do? So a parser, again, is a tool that receives source code as input, something similar to this, for example. And it returns a data structure that is called an abstract syntax tree, or an AST that looks like this. So an AST is nothing scary. It's just like a JavaScript object, which is nested. So it's actually a tree. It is implemented as a data structure that is a tree. So that means that it's just like a nested object with no references to other parts of the, so it's not cyclic references. So yeah, it really looks like this. Just like starts with a node and some associations to other nodes. And as you can see back here, some of the nodes themselves, or the objects themselves, are constructs of the language that kind of are like useful or like identifiable enough. So for example, we can see in the source code, we see like a const hello equals world, which is a variable declaration, and we see some stuff like that represented here. A variable declaration of kind const that holds two things, one thing, sorry, which holds two parts, like the ID and the init, so the initial value and the ID of how to identify that variable, which themselves are also other nodes. So we can see that all the information from the source code is there, or at least the useful information from the source code is there. And once we have this tree, it's actually very easy to do things with it, more easy than just dealing with the strings themselves. So what can we do with an AST? Well, we can do a lot of things. We can first write something that traverses that tree and starts running the code, for example. So we can interpret every node, every construct of the source code of the tree, and then do something with the data as it flows. We can also analyze it. We can like detect some patterns statically by like looking at relationships between the nodes, and get some like reports, some stuff saying how many times this thing is used. Can this thing be used without this other node being declared? For example, like a missing variable declaration. That's very easy to do with the tree shape. But given that it's a tree, we can also like manipulate it. So we can also change it like however we want, as long as the result is still a valid AST. So it's still like syntactically valid. That means that some nodes are not sometimes allowed as childs of some other nodes. So as long as we're careful with that, that's perfectly possible. And we can also do the inverse of that, of the process that we did in the beginning. So we can also convert that back to a string. Okay, so now that we know that, let's go back and see how Babel actually works. And this is like the pipeline for what Babel actually does. So it receives, again, a source code as an input. It's a string of text. It parses it and converts it into an AST, which is then fed into like a set of plugins, which are things that transform that tree somehow. And then Babel takes that final string resulting of applying those plugins to the same AST and converts that back to a string, which is, again, a program that will eventually be fed into the browser, which will, like, in turn, parse it again and execute it at this time. And in a similar fashion, ESLint, again, works by grabbing the source code, which is a string, parses it, and converts it into an AST. This time, it runs it through a set of rules, which, again, are functions that deal with the AST, but in this case, they try to detect some patterns and report some warnings or errors, and that's the final output of the tool. I mean, I'm ignoring in this case the fixing, because ESLint also allows to fix rules, which in turn, in that case, it may be a bit more like similar to what Babel actually does. But for simplicity's sake, we're like focusing on the detection of warnings or errors. Cool. So now let's go and look at a demo. Okay, so I'm in. Probably you can't see the URL because that doesn't go bigger, but this site is called astexplorer.net, which to me is like the de facto place where you can work with ASTs, and like it's actually really cool. Has a lot of like interactivity. So it has two panels. So in the left-hand side panel, you write the source code, and you can see that as I type, as I click, and as I write, the thing on the right updates and highlights the interesting parts of the thing. And what is actually on the right-hand side is the AST. We can actually see that here, for example, we have an if statement, which the condition is a binary expression, where the left-hand side of the binary expression is a member expression, which actually is a nested member expression, where we see like process, then env, and then node env, and then that's equal to something on the right, which is a string literal. So it's pretty clear. It's very easy to see the source code and the AST at the same time and like make sense of it. So this is why, in general, like this is the best place to work with ASTs, because it's very easy to see what's going on. But this is not the only thing that this tool does. Actually, it's not even like tied to JavaScript. You can use any other language because it parses and shows ASTs for different languages. But for our purposes, it also allows us to run transforms. In this case, we can even like run Babel plugins with it or ESLint rules with it. In this case, we're going to be running a Babel plugin. We're going to be writing our own plugin. So when you click on transform and you select, like, let's use Babel v7, we have two more panels at the bottom. The one on the left is the actual plugin, the actual implementation, which is what we're going to be working with. And the thing on the right is the output of running the plugin in the code that was on the upper left side. So it comes with a built-in example that we can see like from the output without actually understanding what's going on. That seems to be reversing every identifier that we have in the code. So this is like still valid JavaScript, but it will probably fail at runtime if we use like some built-in method, because it will reverse that method. That won't exist. But it's worth noticing that syntactically speaking is still valid JavaScript. Okay, so cool. So now let's see what are the parts of like a Babel plugin. So to write a Babel plugin, it's just like exporting a function that will be called with a Babel object, which is actually the API that we're allowed to work with. And in general, the thing that we're interested about from this object is the types, like babel.types. And for convention, and this is what AST Explorer does by default, it addresses that to the t variable. So, but in general, the t is just babel.types. Babel.types is something that you can look at in the documentation. So if you go to the Babel docs in babeljs.io docs, you have the types here at the bottom. That when you click, you have like the documentation for all of the things that it provides, which are like a bunch. Cool. So we're going to be seeing those, some of those in a while. And then the thing that needs to return, like that function needs to return in, like, again, let's obey this comment, and since it's not required, let's remove it. We need to return an object that has a field called visitor, and that is the interesting part of, like, that's the meat of the plugin itself. That visitor is actually an object that will be called in each node, and we'll be executing some functions that we define on it based on the type of the node that we're visiting. So in this case, this method will be called for all the identifier nodes that we find in our AST for the code that we wrote. So this is an identifier, this is an identifier, this is also an identifier. This is not an identifier, this is a string literal. The if statement is not an identifier, it's an if statement. So you can probably see what's actually going to do. And the identifier will receive another object, which is the path, which is actually a wrapper of the node itself. It's a wrapper because it also provides you with some helpful methods. For example, like the most common one probably is like path.replace with, and we can replace the node with anything we want. And for that, we're probably going to be using like a function from the t variable, which is to create a new node. For example, let's replace every identifier with a string literal. This probably won't work because some cases, like some things are not allowed to be, yeah. So let's replace it with another identifier that has the word hello. Okay, so let's do something else. Let's not replace identifiers with identifiers. Let's replace the member expressions. Okay, yeah. So we grab, instead of grabbing all the identifiers, because that may run into some syntactic error, like the thing that I mentioned before, that not every tree manipulation is actually valid. But replacing member expressions for like simplifying, for example, this to this is actually valid. So here what we're doing is like replacing every instance of member expression, which are like calls to like a nested object, like an object calling a member of it, will be replaced by an identifier that's called hello. So you can see here like hello, hello here when we had process.m, but also here and also here. Like for, not in this case because it's not. This is not a member expression. It's just an identifier. Cool. So now let's work on what we actually want to do. We want to build a Babel plugin in this example that works similarly to what the define plugin in Webpack does. So probably not everyone is familiar with what that thing does. So basically what we want to do is like replace some expression in the code with some like constant like literal thing that will be like replaced like with the literal. So in this case we want to inline the process.env node.env to the actual node.env when we compile the code, for example. So we can see here that we want to actually convert this if expression, for example, into production. Like we want to replace process.env node.env to production if the node.env is production. Like imagine that we want to replace that with development if the node.env is development. This is good for production. Like it helps with performance and bundle size because when we run this final code through a minifier, those will be like optimized and will be like stripped. Like we will run like that code elimination, like in the sense that the branches that will actually always be false will be stripped out of the code. So that's less code and less checks to do, and everything runs faster. So another example here, want to do this. In this case, again, replace process.env node.env. But we don't want to replace this one because this is not process.env.node.env. This is just process.env. And also, we don't want to change anything that has nothing to do with process.env.node.env. So the first thing to write a plugin is to actually identify what pattern in the tree we want to identify. So in this case, we know we want to replace process.env.node.env. So we just click on that in the source code and see if we can find the thing that highlights the whole thing. Cool. So it seems that it's a member expression. Let's move this a little bit down. So it's a member expression where the object is also a member expression. So we see like there's a nesting of member expressions where the inner one has the object. The object is an identifier with the name process, and the property is another identifier with the name env. And the outer property, so the property of the whole process.env thing here, is also an identifier with the node.env string literal. So that's what we want to detect. And then the other part of like writing a plugin is seeing what we want to convert that to. So basically, we want to convert that to the production string literal. So we click on any other similar thing that we have in the code, or we write it if we don't have it. So that's literally string literal with the value that we want. So basically, we pretty much have this here. Like this is what we want to do. Like we want to identify member expressions and replace them with identifiers. So let's imagine that we have let's imagine that we're in production. And then we want to replace that with whatever node.env does. And instead of an identifier, we said we wanted to replace it with a string literal. So we're using the t.stringLiteral function from t. So you can see now that t provides you with a way to create nodes by passing some arguments to each type of node, and it has methods for each type that you want to create. This is all documented in here. So if you say, for example, string literal, yeah, this is like what we're using. So and there are also some like helpful methods to check if some node is of certain type, which is something that we're going to be using now. Okay, so we are now transforming stuff to what we want, but it's not really exactly everything that we want to transform. We're transforming more things than we want in this code base. So this is okay. This is what we want. This is also okay. This is what we want, but this is not okay. So we don't want to actually transform this. And yeah, I think that's it for this example. This is all already not changed because we're not detecting, we're only checking for member expressions. And this is not a member expression. This is an identifier directly. OK, so let's look at the pattern. We said that we wanted to have, we had a nested member expression that we wanted to look. So let's check for that. So to get an access to the node, we just use path. We use path.node. Path.node will return us the object that we saw in the example before, which is like just a literal plain JavaScript object with these properties. So we can get path.node.object, path.node.property, and all that. So since we know that it's a member expression, we have those two fields, the object and property, so we can say, OK, I want the inner member. And this is path.node.object. But I actually want to check that the inner object is a member expression. So if is not a member expression, inner member, we just bail out. So we don't care about member expressions that don't have a nested member expression because we are looking for that pattern. So now finally what we need to check is that all the properties, the property identifiers have the right values. So in the inner member here, we want to check that the object has the name process and the property has the name env. And for the outer member expression, we want to check that the property has the name node_env. So let's write that. So let's create a variable called is process env node_env. It will be like a set of conditions. So let's say, OK, so inner member dot object dot name should be equal to process, and inner member dot property dot name should be equal to env, and the outer one, which is in path.node, path.node.property dot name should be equal to node_env. And I'm missing again this. Cool. And finally, we need to make the check. So if it is a process env node_env, we do the replacement. Cool. So yeah, we see now that worked. So we see that the process.env didn't change. These two still changed, and this one, since we were never detecting for it, didn't change. So yeah, that's it. That's how we write a plugin. Obviously, there are probably some extra edge cases that we will need to take care of. But for the most part, this is how you build a Babel plugin. It's just once you find an edge case, it's just detecting the pattern of the edge case and adding more conditions to not detect that edge case. Cool. Let's go back to the presentation. OK, so as I mentioned before, ASTs not only appear in these two tools. You will see them in the wild in probably tools that you use nowadays, like in your day-to-day work. They are all over the place. For example, for type checking, TypeScript or Flow, the type checking is actually done by detecting patterns in the AST. Post CSS, for example, that's a good one that we all use probably. It's the same thing as Babel, but for CSS. It allows us to use new CSS features and implement them in terms of like normal CSS that browsers understand. And there are some other different usages of ASTs. For example, Prettier is like an automated core formatting tool that probably some of you use. And that the way that it works is that it takes the source code, it parses and transforms it into an AST, and then prints it in an opinionated way so that it's always the same based on some configuration. So that's how it achieves whatever you write in any way you write it, and printing that back to something that is stable and consistent for all the team. Cool. So I think, well, I hope that knowing about ASTs will sparkle some ideas for you. So in general, so for example, like you could write an ESLint rule, as we saw before, to validate a deprecated component that is not used in your app. That's probably functions, but it could also be files or UI components or whatever. You could also write a Babel plugin to add contextual debug parameters to every time you call an API or a function in development to aid in the extra information for you to debug stuff. You could use Babylon, which is the Babel's parser, to parse your application and extract I18N messages statically written in your code, as variables, for example, and extract those into a file in a format that is suitable for you to send to a translation service, for example, in an automated way, so you don't have to actually write them twice. So in general, whenever you have something that is readable, that should be readable in development, but should be optimized for production, that's usually probably a good use case for writing an AST plugin if it's not written already. Whenever you want to generate some artifacts from the code, like type definitions from a DSL, like GraphQL or any other, like even your own. Or sometimes if you want to automate refactors, like you can specify how to manipulate that AST from the original code to the migration code, and you can automate that with any of these tools. So, and if anything, if you don't find that useful at all, at least knowing about ASTs will help you Google for things better. So once you know the type of constructs, for example, this new proposal for optional, like the thing that we saw in the beginning for the IDX library, that's a proposal for adding that feature in JavaScript, like the existential chain operator. And that's in an AST appears as an optional member expression. So if you want to write it, find it as hey, what's the question mark after an identifier in JavaScript? You will find lots of confusing things. But if you actually look for that type of node in the AST, you will probably find useful thing, even like the proposal itself, so you can find more information. When I will be sharing the slides, hopefully, and these are like the resources that I use to create this thing, to learn about the ASTs and to build it, to get the data for this talk. You should follow these 3 people for sure. They shared a lot of content related to this. Probably you follow some of them already. So I hope that next time that you are using any of these tools, you look like this. And yeah, that's about it. Thank you.